Welcome to polynomial functions.
Now let's talk about something else that's important, turning points. So turning points are going to be anywhere that the graph changes from increasing to decreasing or decreasing to increasing. If you notice on this part of the graph here, the function is decreasing. And then right here, when you get to this point, it changes from decreasing to increasing. This is a turning point, okay? And then at this point here, it changes from increasing to decreasing. And then here, at this point, now the graph is going up. So it's increasing as we go left to right. And then when we get to this point, the graph switches to decreasing from left to right. And then at this point, now the graph is all of a sudden increasing again. So it's going up right here from left to right. The important point is, notice here that these turning points occur whenever we have a minimum, like right here, minimum. We have 3 minimums, or we have a maximum on our graph. So we have 5 different turning points here. Now, what this says here is that the graph of a polynomial can have at most n minus 1 turning points. So n minus 1. So we have these turning points. There's 5 of them. So that tells us that this polynomial here, this polynomial must have a degree of 6 or greater. It must be degree 6 or greater. It can't be degree 5 because 5 minus 1 is 4. But this has 5 turning points. Same thing with 4. It can't be degree 4 because 4 minus 1 is 3, and that's less. It's only allowed 3 if it has a degree of 4. So a 6th degree polynomial can have at most 5 turning points. A 7th degree polynomial can have at most 6 turning points. But it can also have 5. We're just saying that it can have at most. So this could be 6 or greater. Let's look at example 3. What could be the degree and sign of the leading coefficient of the polynomials represented by each graph? That's our first question. Second question is, given that the graph of a polynomial can have at most n minus 1 turning points, what are some possible leading terms for the polynomials represented by each graph? For part 1, we want to use the leading term test. Notice that our graph extends up to the right and down to the left. That's going to be this top right example that we have here. So A would need to be positive and N would need to be odd. So A is greater than 0 and N is odd. Let's look at the second one. Notice the end behavior is pointing down into the third and fourth quadrants. That's going to be this bottom left case that we have here, where A is less than 0 and N is even. So for this example, A is less than 0 and N is even. For the second part, it says, given that the graph of a polynomial can have at most n minus 1 turning points, what are some possible leading terms for the polynomials represented by each graph? Well, for the first one here, we have 2 turning points. And the graph can have at most and minus 1 turning points. So the lowest degree can be 3. So one possible leading term could be x cubed. If you look, x cubed has a coefficient of 1, which is greater than 0. It is odd, n is odd. And then we could have some other stuff added or subtracted from it. Another possibility is we could have, 2x to the 5th. Okay, again, n is odd and it's a number that's greater than or equal to 3. It can't be less because if it was less, if it was x squared, then there couldn't be 2 turning points. Okay, so these are just a couple possibilities. Let's look at part B. For part B, we have 1, 2, 3 turning points. Okay, since we have the 3 turning points, we know that we have to have at least 3 plus 1 as our degree. Also, we know that the degree needs to be even and a needs to be less than 0. So one example would be negative x to the 4th. Another example, we could have negative 5x to the 10th as our leading term, as long as it's even and it's a power that's greater than or equal to 4, because we have 3 turning points. We have to add 1 to the number of turning points. And also, again, a is less than 0, so these satisfy that. So that's just 2 examples there. Another trick that's used sometimes is to run a horizontal line across the graph, and the most places that it crosses, so notice that it's crossing in 3 places here, is the least degree that you can have for your polynomial. So this one's crossing in 3 places. That's the least degree that we could have. This one is crossing in 1, 2, 3, 4 places. So that means that the least degree we can have is 4. And that really just comes from the turning point definition anyway, but some students, or teachers like to show it this way as a nice visual, but you could do either one.